Good afternoon. Today I will give you a brief about cloud computing. Another 45 to 1 hour. So some of you may be knowing I am Annappa from NIT Surathkal, Coastal Karnataka. This is our campus. So cloud computing, you have seen different revolutions in automobile, various other sectors. Cloud computing is seen as a next revolution in information technology. The way you use systems, the way you pay for different services in IT, that is going to change with the cloud computing. It's already changing in various areas, and most of the other areas it is going to change in the days to come. So it is a next revolution in cloud information technology. So today's talk I will be discussing briefly about cloud computing, what it is and its characteristics, cloud service models, how the cloud offerings are given to different stakeholders, what are the models currently available, then cloud deployment models, how we can deploy a cloud service so that anybody in this world can access to your services. Then one of the enabling technology for cloud computing, virtualization and its advantages. So what is meant by cloud computing? This morning there are some definition given by some of you, and if you search in the internet you get many definitions for cloud computing. But one of the definition given by NIST, United Nations National Institute of Standards and Technology, which discusses clearly about what cloud computing is. It says it is ubiquitous. Whether you access cloud through your laptop, desktop or through your mobile phone, anywhere in the world you can access. Convenient, same service will be available on anywhere in the world, whether you use laptop or mobile phone or any other device. On-demand network access, you specify what type of resource you want, what type of service you want, based on your demand, whether you want high-end machine, whether you want a secure environment, whether you want an application like MS Word or Acrobat Reader, that is available as per your request. That's why it's called on-demand network access. But the underlying requirement is you should have a good network connection. That's why it is on-demand network access. It's not like you go to your computer center and start accessing your server and do your application execution. No, you should have network connection. You should be connected throughout your access to the service to a shared pool of, it is not a single machine. So if you are having a laptop or a desktop, it's a one machine and you will be alone using it unless it is shared using a network. Or if you are having a server at your computer center, a group of students may be using, a group of faculty may be using. But here you are having a shared pool. You don't know from where your request is being serviced. It could be a nearby system or it could be a remote system far away in a different continent. And another feature is which is configurable as per your requirement. You can get the configuration. Once you buy a laptop, the configuration is fixed till next 3 to 4 years, same configuration you will be using. But in the cloud computing it is not like that. Whatever your requirement, based on that you can get. Suppose if you want a high-end machine with 20 GB RAM, your application requires that, yes, you can request, whereas your laptop may not be having that. And you will not be able to upgrade even if you have money. In that laptop, there may be restrictions. You cannot go more than 5 GB or 10 GB, whatever restrictions given in that laptop. But in cloud computing environment, it is not like that. Based on your request, you can request whatever the combination of your hardware or software requirement. So it is configurable computing resources. It could be networks, it could be servers, it could be storage, it could be any application, or it could be any services. That can be rapidly provisioned. How long it will take for you to buy a laptop and start using? Provided you have sufficient money, at least 1 day you need, right? To go to market, buy the laptop and start installing and install your required application software and start using it. At least 1 day you need. But in cloud computing, it's not like that. If you have a proper account with a cloud service provider, and the next moment you can start using whatever resource you need, whatever services you need. That's why it's called rapidly provisioned and released. If you have sufficient credentials with your cloud service provider, then it can be released within seconds with minimal management effort. From your side, managing those infrastructure is minimal. Everything will be managed by the cloud service provider. So you're having very good examples: Amazon Web Services, Google App Engines, Windows Azure, like that. There are so many cloud service provider. Recent notable cloud launches are Zoho or Google services for the cloud applications. For software development platforms, we're having Windows Azure, Salesforce.com, or Google, or if you want infrastructure, servers or memory, storage, we're having Amazon Web Services, IBM, Sun, Rackspace. So this cloud computing has evolved over a period of time. The initial cloud computing concept came something similar to mainframe. You're having a single system, a number of users are using it. Same concept evolved over the years. Now we are having this cloud computing concept. Your Gmail is on the cloud, or nowadays you are accessing your MS Word, MS Access, or any of the applications. You can put your data on the Amazon cloud storage. How easy it is. I can access any of my documents if it is there on the cloud storage from anywhere. I need not carry my laptop or a pen drive or hard disk to have access to those documents. So cloud computing characteristics, features: on-demand self-service. Cloud computing resources can be provisioned on demand by the user without requiring interaction with the cloud service provider. So if you have sufficient privilege to access the resources from the cloud service provider, suppose you are having an account with the AWS, you log into that account, then you can request what is the resource you need. You don't need to call to the service provider or negotiate. You already have an account, and there are steps taken. Suppose you are using a particular service, as per their pricing model, you will be charged. The process of provisioning resource is automated. You need not worry about how to provision. You request the required resources, it will be automatically commissioned to you. And broadband network access. Cloud computing resources can be accessed over the network using standard access mechanisms that provide platform independent through the use of heterogeneous client platforms such as workstations, laptop, tablets, smartphones, various kind of devices, various kind of operating systems. It could be Linux, Windows, or your Android smartphones. If you have a web browser compatible with your systems, you can access any of the services in your cloud computing environment. Resource pooling. Computing and storage resources provided by the cloud service providers are pooled to serve the multiple users using multi-tenancy. So you are requiring a huge computing platforms. Maybe you are doing a research on weather forecasting, or you are doing some research on space related activities or personalized medicine. This requires high performance computing. So first option for you is buy a supercomputer. But the question arises is the amount of money involved, and added to that day-to-day maintenance of that supercomputer. Supercomputer is not like your laptop or small systems. It's huge systems where thousands of processes are running. So you need a special air conditioned room. You need to maintain it properly. Maybe it is water cooled, not the air cooled. So it involves its own expenses, and you need specially trained manpower to manage that. But in case of cloud computing, you can demand the resources. Your cloud provider will guarantee that required resources will be given to you, released to you within few seconds, or sometimes if it is huge demand, it may be within an hour. The resources will be given to you, released to you. So it is through resource pooling. It collects, say Amazon Web Services may be having its own hardware resources to service your request. At some point in time, in case the hardware is not sufficient, they may coordinate with other service providers, send the request to other service providers, and get you the required resources. Something similar to the capability of a supercomputer. Multi-tenant aspects of the cloud allow multiple users to be served by the same physical hardware. Rapid elasticity. Cloud computing resources can be provisioned rapidly and elastically. Cloud resources can be rapidly scaled up or down based on demand. If you are going to buy a supercomputer, you may not be running your weather forecasting application 24/7, or you may not be doing your research on space or medical imaging 24/7. You may be using for 1 hour, 2 hour, 3 hour. Then rest of the day your systems may be idle. So you'll be wasting the resources for power supply, for running the systems. But in case of cloud computing, because of the rapid elasticity, based on your requirement, you can demand more. If the demand is less, then you can shut down those servers. Think that you are having a facility where you have a data center where you are having some 20 machines running. As per the current requirement, request from the clients, you have switched on 20 machines, it is running. After half an hour, out of 20 clients, 15 of them complete their task. So if you see the load on those 20 servers, only 5 are having full load, rest 15 are having 1 or 2 processes running, partially loaded. So you have a provision in cloud computing, you can move those processes which are running in 15 those machines to 5 of them, and you can plan to shut down those 15 machines so that you will be reducing your cost of running those 15 machines. Maybe after another 1 hour, you are getting some more requests, so that the 5 servers cannot serve that request, it will be overloaded. So you can span the servers one by one as the requests come in. So rapidly you can provision the resources as and when you want, and you can shut down those resources, scale up and scale down. Scalability is very good in cloud computing, not like your supercomputers or your conventional servers you are having. Measured service. Cloud computing resources are provided to the users on a pay-per-use model. So to buy a supercomputer or laptop, you have to spend a lot of money. Or if you want to buy a high-end softwares like your MS Word or any high-end softwares like ANSYS for mechanical modeling or 3D AutoCAD or any high-end softwares for software development, whether it is rational rows or for testing Windrunner, LoadRunner, whatever it is. To buy that you have to invest a lot of money. But think that for testing your application, your project, you want a particular tool. Maybe for next 3 months, by the time you will finish your project work. So for that you need not worry about buying that software, or you need a specialized hardware to run that application. Maybe you are doing a project work on sensor networks. You need some sensor setup, it may not be available with you. So you can request the cloud provider to provide that service. You are paying for the amount of time you are using it. For your testing your application, you are using a tool called Windrunner, maybe for 5 hours. 5 hours based on the tool, what you are using, its cost, and they will charge you maybe $1, $2. They have a pricing model, you refer to that, then you subscribe to that service, use for 3 hours, pay that amount, yes, that's it. You need not worry about installing that, maintaining that, managing that software or the required hardware. So it is measured service, pay per use. How long you will be using, what kind of service you are using, what type of resources you are using, based on that you will be charged. Performance. Cloud computing provides improved performance for applications, since the resources available to the applications can be scaled up, scaled down based on the dynamic application workloads. So if you want to ensure that your applications provides required performance, you may not be able to ensure in a conventional client-server model. In a client-server model, server may not be having a load at present. You might have seen in the earlier days when secondary board of examination thought of providing result online. During initial period, on the day of announcement, for example, they announced that at 10 o'clock they will be announcing the result. Every student is eager to see their result, so at 10 o'clock they start logging in, but the server crashes because of this overload. For the next 1 hour or half a day, no student can access their results through that service, because they are having a server. That server cannot cope up with the load. That many users cannot log in. And the recent, forget about that, recent problem with the Flipkart, they had that million-day sales. There are a lot of complaints, even it went to the government level. Many of you might have tried to purchase some items. When you are booking that item, the price was something. When you executed your order, that discount was not there, it came to the original price. Or you're about to order that, by that time it says that out of stock. There are a lot of problems because they didn't expect that kind of load in their servers. If they properly planned using proper cloud infrastructure, that problem would have been avoided. So the performance requirement at that particular moment can be addressed easily by cloud computing environment. Reduced cost. Do you have any argument here? If you are using cloud computing, cost of managing your business can be reduced to a large extent. Especially those companies in their starting phase, those startups, initially they may not be able to invest huge amount of money in their infrastructures. So what they do is they go for cloud computing, or sometimes their business idea may be failure. If they invest huge amount in the initial stages, if that business idea happens to be a failure, the investment will be a loss for them. So for that, what they do is, maybe for the first 6 months or 1 year or 2 years, based on the kind of business they are doing, they rely upon cloud computing. They test their idea. If that clicks, maybe at the end of the year, they may try to have their own infrastructure. In case if their idea doesn't click, they are paying to the cloud service provider on their usage, based on their usage. They are not spent a lot of money. Loss also they are reducing. Cloud computing provides cost benefits for applications as only as much computing and storage resources as required can be provisioned dynamically. How much you need, that you request, that will be given to you. Upfront investment cost is reduced. Outsourced management. You may be having sufficient amount of money to procure the resources, but managing that is not that easy. You need specialized personnel to manage it, look after it day to day. Think that at the end of the day, if your bank server does not take the backup properly, or based on your backup policy, if it is not taken care to take the backup on an hourly basis, in case there is a crash, you will not be having sufficient backup to get it back. It may take hours together. But in cloud computing, you need not worry about managing this. Cloud service provider will take care of managing all your resources, all your data. Cloud computing allows the users, whether it is individual or organizations, to outsource the IT infrastructure requirement to the external cloud providers. Then reliability. Cloud infrastructure is more reliable compared to your individual client server based infrastructure. Application deployed in cloud computing environments generally have higher reliability, since the underlying IT infrastructure is professionally managed by the cloud service provider, and they will be having alternate backup strategy, primary and secondary servers. In case there is a problem with the primary servers, automatically the secondary servers or service provider will be started, and you will not experience in delay in servicing your requests. Multi-tenancy. Multi-tenanted approach of the cloud allows multiple users to make the use of same shared resources. Any number of users can use the same resources, so multi-tenancy allows multiple users to access same resources, same services, same time. Framework for cloud computing. So basically, cloud computing is consisting of service models, delivery models, and applications. Cloud computing can be applied to any domain, be it banking, be it analytics, web, or high performance computing requirements. So I have basically 3 service delivery models: software as service, platform as service, infrastructure as service. These are the three general service delivery models. And you are having deployment models, either it could be public or private or hybrid. Again, there are various other combinations, but these are the main generic deployment models and service delivery models. You could be having a security as a service, as a specialized service model, delivery model, or there could be specialized public delivery models, social or community cloud. Architecture for relevant technologies in cloud computing, you need to have browser to access any cloud computing service, basic device to access, and a browser like Mozilla Firefox or Internet Explorer. Then you need to have a public broadband to access internet. Below that you will be having software as service, whatever software you need to access, whether it is application software or a system software for many different domains. Then if you need platform for developing applications, you need not purchase softwares like rational tools. You can directly use services provided by cloud service provider as platform as service, different platforms to develop your applications, to run your application, to test your applications, or you can request for infrastructure to run your applications. It could be file infrastructures or for mailing infrastructures or database or any kind of hardware. Software as service. Typical SaaS deployment does not require any hardware and can run over existing internet access infrastructures. Suppose you want to access a specific software, a compiler, you want to compile your application, you can directly do it using your laptop or your smartphone. Management of SaaS application is supported by the vendor from the end user's perspective, whereby SaaS application can be configured using an API, but SaaS application cannot be completely customized. So for example, you need an application which is more customized to your organization, then it may not be provided as a general SaaS application. You may need to have a private cloud having this more customized SaaS application in your private cloud. In the public cloud, the SaaS applications are general application like MS Word, it's a general application. Suppose you want to have a specialized payroll model for your organization. You may not find a customized payroll model available in the public cloud. SaaS enables software vendors to control and limit the use of software applications. So nowadays, how many of us buy paid softwares? If you go and ask your student, they know how to get the softwares, how to crack those softwares. But if this SaaS model is deployed worldwide, you can stop that to large extent. It prohibits copying and distribution and facilitates the control of all derivative versions of the software. Since your cloud service provider will be managing it, whenever you're using through the cloud service provider. You're not having a copy so that you can make multiple copies and distribute it. That's not possible. When you're using through the cloud service provider, you're not having a local copy. Platform as service. The vendor offers a development environment to application developers who develop applications and offer those services through the provider's platform. Suppose you want to develop an application and provide as a service to other users in the cloud. You can make use of the development platforms through the cloud provider, develop the application, test the application, and again you can go back to the cloud provider to deploy that application. So when the users access your application, you get royalty based on the agreement you made with the cloud service provider. You get the royalty based on who are all using it. So without any investment on the infrastructure, whether it is hardware or software, you are able to develop an application, kind of application. Then you can deploy that and you can sell it to the user as a service to any public. PaaS solutions are development platforms for which the development tool itself is hosted in the cloud, access to the browser. PaaS is a slight variation in the SaaS model, whereby the development environment is offered as a service. So you are using the development environment as a service. So PaaS is a variation of SaaS model. With PaaS, developers can often build web applications without installing any tools on their computer and can then deploy those applications without any specialized system administration skills. Then infrastructure as service. This model is similar to utility computing, in which the basic idea is to offer computing services. So you are using electricity. It is offered as a service. How much you are using, based on that, it is metered and you are paying. In the same way, computing infrastructure is provided to you. You pay for the amount of processing power, disk space, and whatever other facility you use. It refers to the online services that abstract the user from the details of infrastructure, including physical computing resources, location, data partitioning, scaling, security, backup. Say your application needs higher reliability and it should be secure. You do not worry about kind of infrastructure you need to use, whether you partition your data across multiple servers, horizontal partitioning or vertical partitioning. You do not worry about that. You say that your requirement is your application to be running throughout the day, 24/7, and response time should be less than 3 seconds. Anybody accessing your application, giving a query, should be able to get the response within 3 seconds. Then the cloud provider will ensure that your application is hosted in the cloud servers, so that in multiple locations with replications, they will ensure that your application will be running throughout the day. Anywhere in the world, anybody accessing your applications will be able to get the response within that specified 2 seconds or 3 seconds. It is headache of the cloud service provider. In complete control of the infrastructure, he is controlling the infrastructure, not you. Utility computing users conversely seek a service that allows them to deploy, manage, and scale online services using providers' resources. Today, you may request for a service which can get 200 requests per second. So you are hosting a travel service in cloud computing environment. Maybe locally for this region, you may expect 2000 requests per second. But your business clicks, next month you expand it to other major cities in India. So you expect more number of users, 2000 users to 20,000 users per second. It should be able to service 20,000 requests per second. So you can request the cloud service provider to enable that. Within few hours, he will make sure that that service is available to you. Maybe after a year, you want to expand the business all over the world. From 20,000 requests to, it may go up to 2 lakh requests. Earlier you were working on from 9 to 5, now we want to keep that service open throughout. Yes, you make a request to the cloud service provider, he will enable that. so that your application will be available to anybody in this world throughout the day. Cloud deployment models, you have public cloud, private cloud, hybrid cloud. Public cloud, you don't know who else is on the same server, same network, but in the private cloud, you are owning that, you know who are all using, you can control the access, control the usage, everything you can control. Hybrid is a combination of public and private cloud. Public clouds, or it's also called external clouds, describe cloud computing in the traditional mainstream sense, whereby resources are dynamically provisioned on a fine-grained self-service basis over the internet via web application, web services from off-site third-party provider who shares resources and builds on fine-grained utility computing basis. A public cloud is hosted, operated and managed by third-party vendor. You are not managing it. It is hosted and managed by third party from one or more data centers. They may be having multiple data centers, one in India, one in US and different countries. The service is offered to the multiple customers over common infrastructure. Security management and day-to-day operations are relegated to the third-party vendor who is responsible for public cloud service offering. Customer of the public cloud service offering has a low degree of control and oversight of physical and logical security aspects. As a customer, you are not worried about managing those resources, its security, its maintenance, scaling up and scaling down. As compared to public cloud, private clouds and are also called internal clouds are terms used to describe offering that emulate cloud computing on a private network. You are having a private local area network within your organization, or it could be virtual private area networks. In that you want to build a cloud and you want to enable all your employees to access that in a controlled manner. Since a lot of confidential information, your data you are storing in that cloud, so you want to control the access, so then you can go for private cloud. It claims to deliver some benefits of cloud computing without the pitfalls of capitalizing on data security, corporate governance and reliability concern. So private cloud, you are concerned more on security of the data and the infrastructure, and you may be having special requirement from your organization, corporate governance, how an employee can see the resources, use the resources and reliability of those services what you provide. In that case you go for private cloud. But the problem here is they need to buy, build and manage them. So all the resources you need to buy, then you need to build it, configure it, install it, then manage it. Do not benefit from the benefit of cloud computing, low upfront cost, capital cost and less maintenance cost. The organizational customer for a private cloud is responsible for the operation of his or her private cloud. Private clouds, the network computing storage infrastructure associated with the private clouds is dedicated to a single organization or a single user. It is not shared. So the utilization is up to the organization to decide. Based on their requirement, they may be providing resources in the cloud environment. In case if they are not having sufficient projects to make use of the existing cloud infrastructure, then they may be under loss. They may not be using the resources 100%. Hybrid cloud is a combination of private and public cloud. With a hybrid cloud, organizations might run non-core applications in public cloud. Like you want to give information about your products to the general public, you want to give awareness about your company, the services provided, the kind of social activities you are offering. You want to make it available to anybody in the world. So in that case, those services can be put on the public cloud, but your internal operations, internal development activities, that you don't want to make it open to the public cloud. Then you can have a private cloud. So core applications can be on the core applications, and sensitive data can be in the in-house private cloud. So you are having a combination of both private cloud, which is internal within your premises or in the virtual private network. Other services you are hosting on the public cloud. So you are having a basically the concept is you will be having a firewall which restricts the public user access to your internal cloud. Whereas for the public cloud there is no firewall. Any user on the internet can access. So in the organization we will be having partly private cloud, part in public cloud. That's what the hybrid cloud is. There are various cloud service providers, Amazon, Salesforce, IBM, different kinds of services they are providing. Technologies you need for using cloud computing or developing applications using cloud computing platform. Cloud access device ranging from your smartphone to high-end desktops, browsers and thin clients, high-speed broadband access, data centers and server farms, data centers from the cloud service provider point of view, storage devices, virtualization technologies and APIs. This is the minimum requirement for you to establish a cloud service and start using it. Next is virtualization. Can you give me some examples for virtualization? Many of you are using conventional examples for virtualization. Forget about computing. Conventional day-to-day use. Virtualization. Huh? Google. How many of you are using credit card or debit card? All of you, right? It is what it is. It is virtual money, right? It's virtual money. You need not carry the cash with you. If you have a credit card, it is virtual money. Like that in the cloud computing environment, you may be having a single physical server, maybe high-end workstation or a server with multi-core processors, huge RAM, huge hard disk space, multiple network interface cards. If you alone use it, you may be using 20% of its capacity. If you see many of the government offices, they may be having Windows 8 machine running on Intel i7 or i5 processor. Hardly they will be typing or seeing some emails, doing some application softwares, accessing. They will be utilizing 25 to 30% of that. If that can be utilized to run a program of somebody else when the machine is idle, then you can set up a huge supercomputer coordinating hundreds of systems which are being idle, and it can be used for good applications, medical application. So above your physical infrastructure, you will be having a virtualization layer which enables multiple users to access a single physical machine, giving them the illusion that they are accessing different physical machine. An abstraction of execution environment, it's just an abstraction. So they will provide you an execution environment that can be made available dynamically to authorized clients by using well-defined protocols, resource quota, software configuration. Whether you want to use 2 cores out of 10 cores available in that machine, yes, you specify that. Your hypervisor will enable that. Out of 24 GB RAM available in that machine, your application requires 2 GB. Request for that to the virtual machine hypervisor, it will allocate that CPU. So basically you will be having hardware, above that you will be having hypervisor, and you may be running multiple OS in the single CPU, single physical machine. For having laptop or in your smartphone, you are using at most one operating system, or if it is a desktop, you may have more than one operating system. But in a virtualized environment, the limitation is your hardware capability. You can have multiple operating systems running simultaneously, serving requests of multiple users. Implement abstraction layer, abstraction of physical host machine. Hypervisor intercept the request and emulates instruction from VMs and allows management of VMs. VM technology allows multiple virtual machines to run on a single physical machine. So having different use, it could be Linux or Windows. They are having various virtual machine monitors or hypervisors. There are 2 types of hypervisors, type 1 hypervisor or type 2 hypervisor. Type 1 is a native hypervisor run directly on the host hardware and control the hardware and monitor the guest operating system. Above the type 1 hypervisor, there are multiple OS running. Those are all called guest operating system. Whereas in case of type 2 hypervisor or hosted hypervisor, run on top of a conventional operating system and monitor the guest operating system. So there will be host operating system, on top of that hypervisor will be running, then hypervisor will be monitoring various guest operating system. That's the difference between type 1 hypervisor and type 2 hypervisor. So here in type 2, you are having a host OS, on top of that you are having hypervisor and multiple guest OS is running on top of the hypervisor. Whereas in type 1 or the native hypervisor, you don't have a host OS, directly on top of hardware hypervisor is running and it is responsible for controlling hardware and the guest OS. Hardware and guest OS. There are different hypervisors available in the market. Then there are basically 3 types of virtualization: full virtualization, para virtualization and hybrid or hardware virtualization. In full virtualization, it completely decouples the guest OS from the underlying hardware. That's why it's called full virtualization. The guest OS requires no modification and is not aware of it being virtualized. So there's no need of directly you can start using your Microsoft Windows or Linux, Ubuntu. No need of any modification for the guest OS. Full virtualization is enabled by direct execution of user request and binary translation of OS request. Para virtualization, guest OS is modified to enable communication with the hypervisor to improve the performance and efficiency. So you're making use of hypervisor. Guest OS kernel is modified. Here slight modification is required for your guest OS kernel. To replace non-virtualizable instructions with hypervisor hypercalls that communicate directly with the virtualization layer of the hypervisor. So in the OS assisted or para virtualization, virtualization layer intercept the request and execution of direct OS calls will be done through binary translation. Hardware virtualization. Hardware assisted virtualization is enabled by specialized hardware by the hardware manufacturers, like Intel has VTX hardware platform for virtualization, AMD has AMD V. Privileged sensitive calls are set to automatically trap to the hypervisor. So your hardware has specialized instruction, so it will be trapped to the hypervisor. So it is directly a trap to the system hardware. Hardware has support for your virtualization. What are the benefits of virtualization? Last slide. Enables multiple applications to co-locate on a single physical machine, thereby improving the utilization of your resource. Provides isolation between each application. So applications are isolated. The data they are sharing will not be cluttered. There will not be overwriting or overlapping of applications. Supports resource multiplexing. Same resource can be used by multiple users. Increases resource utilization of physical machine. So your return on investment will be high if you are using virtualization, and virtualization will not cost much. Hypervisors, there are open source hypervisors, paid hypervisors. You can install and start using that to improve the resource utilization. That's all. And there are a lot of open problems in cloud computing for you to research upon, whether it is security or multi-tenancy, resource provisioning, load balancing. Still the load balancing problem is not solved in cloud computing or in the distributed area. There are a lot of issues involved. For you to start working on that. So with that, let me conclude my talk. If there are any questions, I'll be happy to answer.